with touchscreen. It has an Andreessen ProMag 3033A. It's a magnetic flow transmitter. It also uses this Grundfos level pump, or flow pump in this case. To start it up, you simply flip the security switch, you open it up and carefully get the fuses on. Now you see, we get lights. Then we close it back again, not supposed to be inside it when it's on. We wait for the PLC to start up, and now, as you see, if you go to course, then we try to reset it by first pressing stop and then start. A little tricky, but when it works, you see this pump, it starts and it pumps all water through the process line, around the box, through the flow transmitter, through the pipes all the way up to the ceiling, down by the side again, and into the tank. This can go on for many hours, but you probably don't want it to. It gets annoying. And as you can see, if we press reg on this one for regulation, it is here supposed to get a flow at about 80. Right now it's slowly how many liters per second that passes through the pipe. Now if you go back here, you can see that it is almost stable, within 2-3% of what we're about to get. It will stabilize a little bit more, and then it's perfect, quite basically. Then to turn it off again, you go to course, press stop. A little bit tricky as always, but there it works. Now as you see, this valve makes a little bit of vacuum, so it takes a little bit of time, but then all the water runs straight back to the tank. Then for safety reasons, you just flip off the fuses. These will lose their lights, they turn off. And then for a certain safety, flip the security.
Let's take a closer look at how this measurement method works. Two field coils are located inside each electromagnetic flow meter. With the help of what are termed pole shoes, these coils generate a constant magnetic field over the entire cross-section of the measuring tube. Two electrodes which can pick up electrical voltages are installed at a right angle in the wall of the tube. The lining fitted on the inside wall prevents electrical short circuits between the conductive liquid and the metallic tube. If there is no liquid flow, no induced electrical voltage is measured at first between the two electrodes. The electrically charged particles of the conductive liquid are evenly distributed, shown here in water with red and blue particles. However, as soon as the liquid starts to flow in the measuring tube, the magnetic field applies a force to the charged particles. As a result, the positively and negatively charged particles in the liquid are separated and collect on the opposite sides of the tube wall. Now an electrical voltage forms, which is detected and measured by the two electrodes. This voltage is directly proportional to the flow velocity in the pipeline. Together with the known tube cross-section, the flow volume can then be calculated. The greater the flow velocity, and thus the separation of the charged particles, the greater the electrical voltage between the electrodes. The electrodes also detect what is called interference voltage, which has to be separated from the actual measuring signal. One method that has been successfully used for this purpose is to create the magnetic field with a pulsed direct current. To do so, the polarity of the magnetic field is alternately reversed, illustrated here in slow motion. The voltage picked up on the measuring electrodes now constantly changes in polarity. As a result, all constant interference voltages can be eliminated. For example, electrochemical effects in the liquid, or external electromagnetic fields. Thus, the size of such interference voltages has no impact whatsoever on the actual measuring signal. The advantages of this are a stable measurement and a stable system zero point.